Minneapolis is being attacked by zombies. Oh yeah, it's real. It's happening. And here's the situation with that. Okay? Each zombie turns two more people into zombies every 24 hours. So that basically each zombie turns into three more zombies after every 24 hours. So on day zero, there's a zombie introduced to the Minneapolis population. And then on the day one, there's two more, making three. So on day one, there's three zombies. And then each of those zombies turns into three new zombies. Okay? And so on day two, there's nine zombies in all. And then on day three, after another 24 hours, each of those zombies turns into three new zombies. And so there's then 27 zombies on day three. And it's crazy go nuts town. And so we are, and this is what we know. We know that if 6,561 people are turned into zombies, we will have panic. We also know that if 2,824 people turn into zombies, the complete infrastructure of the city will go. Like, people will stop going to work, the water will stop working, there'll be no electricity. It's insane. And we know that there's 413,651 people in Minneapolis. And so at that point, everyone will be zombies, okay? And so you were asked, when will these things happen? When will panic strike? When will 6,561 people turn into zombies? When will the infrastructure go? That is, when will there be 206,824 zombies? And when will everyone turn into a zombie? And that's when you say, welcome to the world of logarithms. Woo! Okay. Now, you probably have maybe seen something like this by now, okay? Log 3 of 6,561 equals 8. Okay, and you're like, it's a bunch of confusing numbers and I don't stop. No, stop. Okay, whoa. Let's just organize it here. What's really important is how do logarithms work? How do they work? That's all you don't have to know how to calculate them. You just got to know how to use them. Granted, there's some situations where it's a little more difficult to use them, but we just want to know what they mean. Get a grasp of what they mean. That's really the most important thing. Okay? So when I see this number, you see problems like this, okay? Let's just focus on the number on the bottom. And let's just say that when you see this, log 10, we call that log base 10, all right? When you see log 2, that's called log base 2. Now, I know there's supposed to be another number here. Oh, is there? This is the thing that's important. Log base 10. What does this mean? When you see log base 10, that represents a list of numbers. And these are the list of numbers. 10, 100, 1,000, 10,000, 100,000. Okay? That's log base. It's a list. This is a list. Log base 10 is a list of these numbers. The first number is 10. The second number is 100. The third number is 1,000. And the next number is 10,000. Okay? Now, what's interesting about this list, one thing that's interesting about this list is that if you multiply any numbers in the list with a number that's also in the list, the answer will be in the list, right? So 100 times 10 is 1,000. Oh, yeah. That's, 100 times 1,000 is 100,000, right? It's in the list. So when you multiply any of the numbers in the list, the answer will be another number in the list. That's nice. Okay, they stay in the family. That's what I'm saying. Okay, so this is a list. This is another list. It's called log base 2. Okay, so when you see this, it's really talking about a list. And this is the list. 2, 4, 8, 16, 32, 64, right? Now, you may recognize already that these are all, of course, powers of let's see. Yeah, powers of 2, right? Because here's 2, and you multiply this by 2, and you get 4. And you multiply this by 2, you get 8. And you multiply this by 2, you get 16. And you multiply this by 2, you get 32. Oh, right. Same thing here. Multiply this by 10, you get 100. Multiply this by 10, you get 1,000. And that determines the next number. So that, of course, the first number is 10 to the 1. The second number is 10 to the power of 2. The third number is 10 to the power of 3, right, on this list. Okay, so that's what we're talking about. So here's what the application of the problem is. When you see this expression, log base 10 of 100,000, what it's really saying is, where is this number in the list? Where is this number in this list? Well, this list is right here. Well, where is it? No, it was 100,000. So let's see. 1, 2, 3, 4, 5. So the answer to that is 5. Okay? That's what the question is. Where is 100,000 in the log base 10 list? Okay? That's at least one way to think of it. I think it's a good way of thinking of it. Okay? This is asking, hey, where's 64 in the log base 2 list? Okay? You know what this means. This is a list. And I was throwing a number at you. Like, what? No. It's just saying, yeah. So you know that list, log base 2? Oh, yeah. Where is 64 in that list? Okay. 1, 2, 3, 4, 5, 6. 6, right? Now, of course, you should know that log base 2 is referring to, it's a list. But the thing about this list, this is actually the powers of 2 list. It's a